Welcome to Microsoft User Group Singapore. This session is being recorded and live streamed to YouTube and Facebook. And you do not consent from being recorded, please disconnect now. To ensure a good recording, please take mute your voice if you're not speaking. With that, please welcome our host, Niels Gill. Invest your time.
Okay, thanks, Ruth. Hi, everybody. Thanks for joining us. I see many familiar faces already in the MS Teams. If you're joining us from YouTube or Facebook, thanks for joining in. This is the people who organize this Azure Singapore user group. If you want to get in touch with us, you can contact any one of us, Saktis, myself, Rivut, or Sentamil, for arranging any sessions. Or if you want to present a session yourself, please feel free to get in touch with us. Here are some of the sessions which we did over the last 4 weeks. I've also created a URL short link for all sessions that we did as part of Azure Singapore, so you can find them easily. If you have missed any of these sessions and you would like to see the recordings of this, these are all available on our YouTube channel, and you can find them easily using this short link. What's coming up in the coming weeks? Next week we have John Saville, who will be joining us for second session of his. This is about private link and Azure Private DNS. And then we follow that.
You didn't share your screen.
Oh, is it? Sorry.
Yeah.
I was wondering as well.
Oh, sorry about that. I don't know how the sharing stopped. I thought I tried sharing. Okay, let me do it once again. How about now?
Yeah, also, yeah.
Okay, so let me just quickly go back to the 2 slides that I was talking about. So this is about the organizers, Saktis, myself, Rivut, and Sentamil. You can get in touch with us. I've given the contact emails here. And this was the short link I was talking about. So you can go to bit.ly and Azure Singapore sessions. You can find all our session recordings here. And in the coming weeks, we will have, next week, we have John Saville joining us for his second session about private link and Azure Private DNS. And this will be followed by Christopher Noring. He will be talking about ARM templates. And in November, we have IoT data architecture by Dave Glover. In between these 2 sessions, we also have a couple of other sessions which I'm yet to publish on Meetup. Do look up on the Meetup page. I'll publish them very soon once we get a confirmation from the speakers. And apart from our Singapore Azure UG group, there are also other user groups which are managed by our fellow MVPs, and Setu and Priyanka, they are running this AI and machine learning. And next week on 6th, they have this 2 sessions. Setu is running reinforcement learning and he's doing part 3. And we also have a speaker from Germany, Rene, who would be talking about spatial computing. So if you're interested in AI ML, please feel free to join these sessions. Apart from these user groups, we also have a couple of boot camps which are scheduled. I mentioned them about in our earlier sessions as well. These are currently scheduled in November. So do look forward in our Meetup pages. These are already published there, and we will be updating as and when we get more details. If you're new, please feel free to join our YouTube subscribe channel, and you can find a lot of valuable videos here. These are not just the user group sessions. We also have Azure Bootcamp and other community events which are done by the MVPs in Singapore. Here are some of the popular sessions which are so far very famous or regularly watched by our YouTube subscribers. Now, coming to today's session, we have Abhishek Gupta, who is joining us all the way from Delhi in India. He is a senior cloud developer advocate with Microsoft, and he is quite passionate about open source technologies and distributed systems. I put the links to his social media handles here. I will also put it in the Teams chat. And before I hand it over to Abhishek, quick reminder of some of the housekeeping rules. Please keep yourself on mute while the session is ongoing. If you have any questions, please use the raise hand feature of Teams, and you can unmute yourself when the Q&A is going on. This session is being recorded, and if you find these sessions useful, please help us by spreading a word on your preferred social media channels. With that, Abhishek, the stage is all set for you. Over to you.
All right, awesome. I'm going to try sharing my screen first and make sure you're set there. And so Let me know how that works for you. Do you see a raccoon here and the
Yes,
slide? All right,
yes, I
awesome,
can see it.
awesome. All right, perfect, perfect. Thank you so much, Nilesh, and the entire team for first of all having giving me this opportunity to be here and for inviting me to talk here and letting me connect to this new Azure community at Singapore. I haven't done that before, so thank you so much. And thanks for the introduction. So again, my name is Abhishek. I in addition to Go. I also work a lot on, like Nilesh said, cloud distributed systems, specifically speaking, things like Kafka, databases, Kubernetes, and I also work on advocating and contributing to some open source projects still. So my Twitter handle and GitHub handle is here. My DMs are always open. Feel free to reach out to me. All right. So what's the plan for today? So I'm going to try my best and start off by selling you Go. When I say Go, the programming language. And so this is ideally speaking, this presentation or talk is for folks who who are either like new to Go, new to Azure, or new to both these technologies. Maybe this is the most suitable for those kind of audiences. If you are an expert in Go and Azure, both of them, if you happen to be an expert, you may find it a little high level, but then still it might be a refresher for you, right? So that's that. I'm going to chat to you about Azure and Go. Excuse me. And yeah, it's really hard in a space of like 30 to 40 odd minutes to be able to cover everything. So time and again, I'll share what I call some links. They are not clickbaits. They are genuinely useful information. They might be links to my blogs or generally documentation or things like that. They are genuinely going to be useful. So feel free to sort of explore them and look at that collateral information when you have time later, when you want to look at this presentation or go through this talk again. And of course, I have a few demos lined up for you, and I've given my offerings and pray to the demo god. So we'll see how that goes. And the best time for a question is when you have it. But then my request would be to ideally, if you can, just park it till the end, if that's possible. But if it's like a really burning question, feel free to interrupt me. That's fine. But ideally speaking, just if you can have it at the end, I would really appreciate it. And these bits which you see, these cool little cute pictures right here. So this gentleman right here is a raccoon. These are designed by Ashley McNamara, who is also a developer advocate in our team, fortunately. So this guy is the developer advocate. We call them bits. And this guy right here is just a makeover or a different avatar of the original Go mascot. We tend to call them Gophers, right? So you'll heard the terminology Gophers very often. So Go developers or Go lovers or Go enthusiasts also like to call them Gophers. So do I. So the raccoon, the advocate bit, and the Gopher right here, right? So they are friends, and that's what I'm going to talk to you about. Yeah. Uh, Pretty much everything I'm going to talk about is going to be available here on this link. Super simple, Azure for Gophers, ako.ms at the beginning. This points to a GitHub repo. Not everything is there right now, but I'll make sure that I make it available, sometime after the talk. So yeah, you don't need to like remember anything else. Pretty much this. All right, so let's start off with what is Go really, right? So Go, simply speaking, it's an open source programming language, right? It's just another programming language. It was initially developed at Google by Rob Pike, Ken Thompson, and Robert Griesmer. Those three, of course, there are other folks as well, but primarily they were the harbingers and the co-creators and initial designers of the language. Like I said, it was born in Google, and I think it first came out in 2009, somewhere in November, if I'm not mistaken, right? Yeah, so I cannot escape a customary hello world, right? So typically, if you write a Go program, you would write your program in .go files. Essentially, the entry point is captured within a file called main.go. That's typically the name. It could be anything. For example, in Java, if there's a main function, the same goes for Go. You have a main function, you can enter whatever you want there. That's the entry point to your program. And to run it, you run Go run, right? So Go is essentially the entry point to the Go toolkit system entirely, right? So that's the command line tool for building, running, dependency management for your Go applications, right? So pretty simple, and yeah. Okay, so some of the good and bad about Go, and this is purely my personal opinion. If you look around on the internet, you will find different views and opinions, of course, and all that's good. So, from my perspective, some of the good parts of Go are it's first of all its simplicity, right? And when I say simple, it doesn't mean like it doesn't have features, or it is like you cannot do stuff with it. No, that's not the case, right? And I would really highly recommend you to again click on that link later on and check out that talk by Rob Pike. Simplicity is complicated. So when I say simple, I really mean from a cognitive load perspective, from a learning curve perspective. It is really simple to get started with Go and write something relatively useful, right? So that's what I mean by simple and simplicity. It is a really good standard library, like most programming languages have, to be honest with you. It's really solid, gives you a lot of flexibility. I'm sorry, gives you a lot of capabilities which you can use out of the box and even learn from that code, right? More often than not, Go gives you like one way of doing things. It's not as if you can be smart with Go. I'm not saying that you cannot be clever and all, but by and large, you will see that there is one good way of achieving something, right? It might be, say, concurrency, or it might be anything else, right? So that's definitely one thing I like about. And and this one hard to change, right? Many people in the community have actually, this is not their favorite thing, right? Because when they try to go to say they think about changing the language, updating the language, adding more features. Generally, the Go team and the community in general tends to be very, I wouldn't say closed, but very careful about it, right? Especially the Go design team at Google and the other related Go maintainers, right? So what it ends up being is, sometimes the language seems to be boring. Release after release, you don't see a lot of exciting features, but it is solid, right? It works, and there is less fluff, right? So they're not too many things which are there but you would hardly use. So that's what I mean by less fluff, right? And again, Rob Pike has a lot of opinions on this. I really encourage you to go and check out some of his talks. uh, what I don't like is, and one of the things is dependency management. It is improving right now since Go 1.11 with something called Go modules. But so far, before that, and even now, things have been changing quite a lot, right? And no one likes a lot of change. Especially in something as foundational as things like dependency management, for that matter. And if you look at other up and coming languages, one of the examples is Rust. Dependency management out of the box is very well supported. So that's something which I have found difficult about Go a little bit, but it is improving very rapidly. And another thing is application structure. So there seem to be a lot of opinions about how you want to structure your applications for different things. How to structure command line applications, how to structure, say, web APIs, or other kind of services which you're building. So there are a lot of opinions, a lot of inputs. Of course, you can within your company, your team, you can standardize that. But if you're starting with Go as a team, this is something which you'll have to deliberate upon, as opposed to, say, something like Java or even other languages, for example, right? I'm mostly Java and Go person, so I cannot give too many examples. But like with Java, right? You have a Maven archetype, you have the structure right there. So yeah, you'll have to think about it when you start off with Go, but I'm sure you'll find it comfortable once you're set. And what is it good for, right? What can you really use it to build? Now, there is literally no limits, right? You can use a programming language in any way you want, and the same goes with Go. But these four are categories. I just want to make sure I'm here. Can you hear me? Just want to check.
Yes, I can hear you.
All right, perfect. Sorry, I this is for a second. I thought, all right, okay, cool. So what was I saying? Yeah, so these are the four high-level categories. Building cloud services. When I say cloud services, I mean both building the service itself, maybe foundational services within Azure or other clouds, or building for the cloud. And that's something which we are going to talk about and discuss during the course of this presentation, right? Building these web applications and APIs. When I say web applications, it's not like purely like full stack applications, like, say, with Node.js or something like that. No, it's mainly for these backend server side APIs. So Go is really dominant in this, like I said, these backend applications, these APIs, these networking services, these cloud services. And CLI apps, this is actually my personal favorite. I'll be honest with you. During my like 11 to 12 years of experience, and I have a lot of experience in Java, I I didn't like to touch CLI applications or go ahead and build it. But with Go, I mean, it's like I find an excuse. I try to find an excuse to try and build some CLI applications. It has whether it is the standard library or some of the very popular CLI open source libraries which can actually help you build CLI apps in Go. I love building CLI apps, and you should try it as well. I think that's actually an ideal way as an entry point into Go. I would actually recommend that. And finally, but not the least, I mean, I don't have a lot of experience in the SRE and DevOps space, at least not building these services with Go. But yes, it is very popular. So people build CI/CD systems, so they're like proper CI/CD products built in Go, and people also use to actually build their SRE infrastructure, so on and so forth. So yeah, these four are the top categories for Go application in the real world, if you may. If you talk about the cloud, to be very specific, and why Go is so popular and dominant in that categories, and there are a few reasons. And obviously, this is not a complete list, but these are some of the top reasons which I know of personally, as well as from the community and in general. So Go has a very low resource overhead, as in, like I don't want to compare it to any language or JVM. People tend to do that. Like, Java has been bread and butter for me as well. But I'll be honest with you, from a resource consumption perspective, Go definitely is up there. I know with Java you have Quarkus and other runtimes which can help you reduce the resource overhead, but it is sort of built into Go right from the get-go. Standard library, again, repeating this, it has a lot of it is very solid, so to speak. It has these features built right off the box: concurrency, HTTP, RPC, be it using gRPC or JSON over RPC, solid support for SQL databases, so on and so forth. So that makes it very ideal for interacting with these external systems. And I forgot to actually add very solid networking support as well, and IO support. So I should have added that, but I forgot. But yeah, that's there in standard library. Solid, tooling, like profiling, benchmarking, testing. It's built right out of the box. And the fact that you can actually compile this as a static binary. So what I mean by that is you can say, hey, compile this Go application of mine for Linux, for Mac OS, or for Windows, and that's it. Or there are other combinations and permutations which are possible, and you just have that one artifact. Just push it to your VM or your in a Docker container, whatever it is, whatever that platform or that channel is, for you to ship your application, and you're good to go. Right? Of course, it's different. It's same with Rust as well, but not with many of the languages out there, right? And as you can see, for CNCF, Cloud Native Computing Foundation, if you're not familiar with it, projects like Kubernetes, Prometheus are a part of that, of the Cloud Native Computing Foundation, and a lot of projects. I think it's over 75% by now are actually built in Go, and some of them are built in Rust as well. So it's really picking up, languages like Go and Rust in the cloud native ecosystem in general. If you want to go, get started, my recommendation would be to just follow the installation instructions for Go. It should be pretty simple, and especially if you are like an experienced programmer, right? This should be good enough for you. Like, install VS Code. I would definitely recommend VS Code, not because I work for Microsoft. VS Code is open source anyway. IntelliJ IDEA also provides good Go support, but it's not free. So do that. Take a tour of Go. Just go play around with the language, learn the syntax. Write some toy programs, and then read Effective Go, which is sort of a good way to understand idiomatic Go and how to write good Go code. And I think you are well on your way. I mean, you won't be a master in Go, but I think you will have covered a solid ground in terms of getting started with Go. And don't miss these folks. At least like I'm sure there are other Go experts out there which you might know of, but these are the folks I would recommend. So Rob Pai, Carmen, Samir Ajmani, all these folks happen to be Googlers, just by coincidence. So yeah, check them out. Check out their talks, content, and they're awesome. Okay, so if I have not managed to convince you, like, everyone likes to see posters of companies, but actually more than that, like which company is using Go. Personally, what excites me is, and because I work in this areas of cloud, distributed systems, databases, it excites me to see projects like Docker and Kubernetes, who were like sort of the poster child of Go from the beginning. And there are other projects like Vitess. It's like a sharding system for MySQL. Nats is a distributed messaging system. Prometheus is a time series databases. You see here this logo. This is actually a distributed database, CockroachDB, written entirely in Go, which provides you a PostgreSQL protocol. It's so awesome to see so much solid Go projects which are built entirely on Go. Like it's amazing. And yeah, that's the proof is in the pudding, as they say. All right, so what's up? So what's in store, for you as far as Go is concerned, and as far as Azure is concerned, right? So let's chat a bit about that. Okay, so first off, I'll start off with the Azure Go SDK, right? So Azure has SDKs in a variety of languages, including .NET, of course. Python, Java, and Go, of course, is also another client SDK which Azure supports as a first-class citizen. So essentially, this is just a set of packages for you to manage Azure services, right? So what can you do with them? Typically speaking, when you use a client, you would use an authentication mechanism. So the SDKs provide you that, right? You can authenticate using a variety of ways, using a client secret, username, password. You can authenticate locally using your CLI context, Azure CLI context, so on and so forth. And you can manage resources, right? What are resources? Virtual machines. It might be database accounts like Cosmos DB. It might be key vaults, you name it, right? Pretty much all the services in Azure, and of course, there might be a few here and there, but pretty much all the services in Azure are covered by the Azure Go SDK. And I want to clarify something, this terminology of managing versus using. And this is something which I was myself confused when I first started, exploring the Go SDK. So when I say managing, it is mainly about creating these resources. So creating a virtual machine, attaching a disk to it, so on and so forth, right? That's typically called a control plane operation, versus say using, which is called a data plane operation. So using would be, querying a Cosmos DB account, right? The database which you have created or the container which you have created. So they are two different, functionalities altogether. So for the data plane part, or for the using, Go services, so there is a specific SDK for each one of them. So for example, if you click on this link, you can explore them. So there is a separate SDK for event hubs, Azure event hubs, which is messaging system, or event grid, or say Azure blob storage, Azure file storage, Azure storage queues, so on and so forth. So there are specific Go SDKs which are completely different from the core Azure Go SDK itself. And I thought I should make sure to clarify that. That's something which bit me like earlier when I initially started, like I said. I am going to talk about the Go and cloud native ecosystem in Azure a little later. So I'm not going to give you too many details right now, but mostly I'm going to talk about PaaS and containers and Kubernetes, all the good stuff. So that's covered in a later section of the presentation, but I'm going to do that as well, just FYI. So that's that. And another bread and butter area of mine, databases, right? So Azure does give you a lot of options in terms of relational databases, which are like fully managed for you on Azure. You just need to spin them up. So MySQL, PostgreSQL, MariaDB, SQL Server are some of them. And using Go along with these databases, I mean, you don't have to do anything special, right? There's no overhead as such. Just use the standard libraries. So one of them is, like I alluded to earlier, Go has a very solid standard library, including SQL support, right? Just like JDBC in Java. So there is the DB/SQL in Go, right? And there are other helper libraries which I've personally used a lot and like a lot, and I've mentioned them, like SQLX and Squirrel. They can work on top of the standard Go library, the SQL library, to make your life a little easier, right? So out of the box, you don't need anything special. Just use the database, DB/SQL library with any of the RDBMSs on Azure, and you should be fine, right? And if you talk about very specific databases, so for PostgreSQL, there are a couple of popular Go libraries, Go drivers, libpq and pgx. libpq is very, very stable. It doesn't have a lot of exciting changes coming up now and then. So and they themselves call it out, and they actually recommend using pgx the second library here, which has a lot of native PostgreSQL features as well. So it supports a lot of native PostgreSQL constructs, like, there are a lot of them, right? So it supports them pretty much out of the box, like the JSON support and Store and so on and so forth, right? Same goes with MySQL. MySQL is actually, I think it is about like more than 10K GitHub stars, if I'm not mistaken. So it is like battle tested. It's productionized MySQL driver. GitHub is actually one of the teams which uses heavy user of MySQL, as well as the Go driver. And this is a link to a very interesting blog post. Not if you're not an advanced Go user or advanced MySQL user, you might find it a little hard. But then I still recommend using it just to figure out as to how GitHub uses Go and MySQL and the Go driver in general, and those corner situations, and how they resolve it. And not to forget SQL Server. Yes, there is a Go driver for SQL Server as well, although it's not the most popular. I have to be like very honest about it, but yes, if you need to use it, it's definitely there. Another favorite of mine is Redis, right? I am, just like Go, I'm a Redis fanboy as well. And the combination of Go and Redis is, in my opinion, it's like unbeatable, literally unbeatable, right? So for those of you who might not know, although Redis is very popular, it's the full form of Redis is remote data structure, server, right? So essentially, it's kind of a Swiss Army knife. It gives you, these a lot of capabilities out of the box, thanks to the data structures which it supports, right? The fundamental data structures like lists, sets, sorted sets, and some of the advanced ones as well. Like, I'm not going to go into all of them, obviously, right? So some of the capabilities are, you can use it for caching, PubSub, whatnot, right? But the important thing is that at least one of the couple of libraries which I use very often is what you see here, Go Redis, and the Gorilla sessions. So Go Redis is essentially a very stable, well-performing client for Go client for Redis. I use it literally day in, day out, or for any time I reach out to do any Redis work with Go. Go Redis is my go-to driver, and I recommend you using that as well. And if you have very specific use cases, like I said, for distributed session management, so Gorilla Sessions library is actually like a high level. It abstracts over these various implementations, and Redis happens to be one of them, right? And if I did not already mention, of course, there is a managed offering for Redis on Azure as well. It's called Azure Cache for Redis, although I strongly believe that Redis is more than a cache, but it is what it is. And recently, if you may, if you're not aware of it, Azure Cache for Redis actually announced an amazing partnership and collaboration with Redis Labs, who, by the way, I love a lot as well. They also have a cloud offering for Redis. So essentially, there's a partnership where there are different tiers now which are added to Azure Cache for Redis, and it leverages the expertise of Redis Labs to offer you things like Redis modules, and in terms of much more, in terms of infrastructure, much more richer capabilities, right? Things like SSDs and so on and so forth. So again, like I said, there are links. Check it out if that's something that interests you. All right, databases don't stop there, right? So we have spoken key value, we have spoken about RDBMSs. Now the other categories of NoSQL is again Cosmos DB, right? So a fun story. So Cosmos DB, when I was not actually in Microsoft, which was like, it's been 1 year since I've been here. So I heard about Cosmos DB actually in one of the talks by a gentleman called Jonathan Ellis, who is the founder of a company called DataStax, which runs Cassandra as a service, and it's essentially a Cassandra shop, right? And more than just Cassandra, actually, to be honest. So he was talking about how awesome Cosmos DB is, and specifically in terms of the spectrum of consistency levels it provides you, right? So it's much more than just if you are familiar with distributed systems terminology, or you've worked to any relative depth within databases, distributed databases in general. So consistency is one of those terms, right? So typically it's about strong consistency or eventual consistency, right? But Cosmos DB actually has a lot of other spectrums of consistency, right? And that was actually Jonathan Ellis himself was really appreciating Cosmos DB's approach there. So that really attracted me initially, and I checked out what the heck this thing is. Yeah, and the beautiful part is that it's a multi-model database, right? And it is really, trust me, it is really hard to do this, right? By do this, I mean offering a variety of APIs, a variety of technologies, and maintaining these properties of being globally distributed, being like scalable across the globe, right? It is available in almost all the 50 50 odd regions in Azure, and being like giving you that millisecond latency, it's tough, right? So it gives you this SQL core API out of the box. That's like the native Cosmos DB API, and it supports these open source proxies, so to speak. Excuse me. That's my alarm. Sorry about that. And it gives you these open source proxy APIs as well, right? So we are not running Cassandra clusters. We are not running MongoDB clusters in the backend. No, it's mostly the API which Cosmos DB gives you, and you can talk to Cosmos DB using any Cassandra or MongoDB driver. I don't work a lot with graph databases, but there is support for there as well. And it also supports etcd. I believe it's in preview, maybe not. You can check it out for yourself, maybe. etcd is very popular because it's used as a data store for Kubernetes itself. In case you didn't know, it's also a distributed key value store. Yeah, so that's that multi-model database for you, Cosmos DB. And again, nothing special for you to do. Like I said, MongoDB and Cassandra have pretty good support for Go. MongoDB, the team behind MongoDB itself has a well-supported official Go driver, although it should have happened a long back. But I think they started working on it a couple of years back, and now it has matured significantly. And I've used GoSQL for Cassandra as well. It is quite promising, right? I've actually written a decent amount of applications. And if you want to go get started with these open source APIs, these open source databases using a single distributed database at the backend, so check out these, quick starts and some of the blogs. These are my blogs, links to my blogs. So shameless plug there. But I feel they'll be genuinely useful for you if you want to get started with Go on Cosmos DB and these open source APIs. So check them out. And finally, a shout out for Kusto or Azure Data Explorer, right? Because it has very good Go support as well. This is not in the traditional NoSQL or the RDBMS world. It's more for big data analytics, but it has solid Go support. Well, when I say solid, one of the it's on the way to becoming solid, to be honest with you. It's being worked upon very aggressively by the internal engineering teams. I interact with them very often. So yeah, again, it's divided very clearly between two parts. One is for executing those operations, for using Azure Data Explorer and managing those Data Explorer clusters, right? And I've written a two-part blog series. So I would recommend, if you're interested at all, I think it should be a valuable resource for you to go and at least get started with, how to use Go and interact with these with Azure Data Explorer in general. And actually, when I was prepping for this talk, I found this really, really handy link. So I recommend. I'm not going to talk about this in extensively, but it's like a very good table for comparing these different offerings. I recommend you check it out if that interests you, right? So it's like everything in one place. It gives you a very good snapshot. I just discovered it today, to be honest with you. So that's a good one. Okay, talking about distributed systems, let's not forget messaging, right? Messaging systems for asynchronous communication, right? Because you can only go so far with, sending these JSON payloads over, general RPC or over just HTTP, right? So you will need, if you are building a scalable system, be it microservice or whatever model you're following, you have to use asynchronous messaging. And when you talk about messaging on Azure, there are 3 different offerings. Like, I'm not going to talk about them extensively. There are links here. So it's event hubs. I work extensively with event hubs. It also gives you like a Kafka endpoint. Not so much with Event Grid and Service Bus, but yes, they are pretty solid, very well matured messaging systems. Customers have been running workloads on this, and obviously goes without saying that there are Go SDKs for this, right? So if you were to use event hubs, for example, with its Kafka endpoint, so there is like it has nothing to do with Azure as such. So there is a Kafka Go client. There are multiple ones. So by a company, it's a Sarama Go library. The one there is another one by Confluent. a Go client for Kafka, and there are a few others as well. So if you use event hubs, if you use Kafka with event hubs, yes, I'm pretty sure you're going to find a home as far as Go is concerned if you're building systems with Go. And just to top it off, I'm not going to talk a lot. Of course, Go, it actually goes without saying, like, it's not just about Go, to be honest with you. Like DevOps and GitHub Actions, which are CI/CD tool sets, and Azure App Insights for monitoring, and of course, not to forget VS Code. Like I said earlier, it has pretty good Go support. I'm saying pretty good. There are obviously some, there have been some complaints, and personally, for me as well, there are some ups and downs. But then by and large, like 85 to 90% of the time, it works very well, right? So yeah, if you are a Go developer, VS Code, like hands down. Unless of course you have other options, you can pay for them. No problem at all. Alrighty, so let's talk about cloud native now, right? And there are going to be some, we'll see when that comes, right? So the cloud native ecosystem, and I'm alluding to Cloud Native Computing Foundation, the CNCF to be specific. There's a lot of things to think about when you say the word cloud native, especially in the context of CNCF, right? There's so many technology categories. So starting with microservices, which in itself is like a huge category, containerization, DevOps, where to store your data, and of course observability, and of course service mesh, right? So a lot of things to think about in the cloud native ecosystem, and yeah, the community and the developers have their, so this is not like literally I have no words to describe this slide, but I did find this meme on Twitter thanks to this gentleman. You can check this out. If you check out landscape.cncf.io, you will get this huge, I mean, I found it so hard I couldn't paste it on the slide, so there it is, this meme, right? You can literally have this on on like a huge board right there, and keep exploring the entire ecosystem. But just to set the context, right, I'm going to talk about just these things. Infrastructure, not so much, but then there's this spectrum which is created, right from infrastructure to PaaS, to containers and serverless, right? I am not an infrastructure expert, I'll be honest with you. For me, when you say infrastructure, I think VMs and I think lift and shift, right? So obviously infrastructure, or IaaS, is a good story. You can bring your Go workloads as VMs from your on-premises environments, but don't forget networking infrastructure and the surrounding technologies as well, right? So that's my main story. I'm not an expert. I'm not going to talk too much about infrastructure, but it is there for you if you are looking to, like I said, migrate or lift and shift your Go apps on-premise to the cloud, right? That's actually a very preferred way, to be honest with you, for customers to first dip their toes into cloud, so to speak. PaaS, or platform as a service, right? So one of the go-to services for many customers on Azure is Azure App Service, right? Fully managed, like with pretty much all the Azure services. It's mainly for these, web apps, like literally full stack web apps, APIs. You can build MBAS, mobile backends as a service. Supports a lot of languages, like natively. It has out-of-the-box support. Not for Go, like it has Java, .NET, Node.js, but don't be disappointed. It supports multiple operating systems as well, Windows, Linux, and Docker containers. And that is where Go support comes in. That's fine. I mean, down the line, Azure App Service might support Go as a first-class language. I would really be happy about it, but you can use Go with Azure App Service because it supports Docker. So, for example, this chunk of code which you see right here, I'm sorry if it is like not very obvious to you, is it's just an example of how you could potentially say build a very simple API layer on top of something like Azure Cognitive Services to be able to invoke it and do something as simple. At least for an example, it's a language translation example, but the fact is that you can build this API system, these REST APIs, and these web applications based on Go using just the standard library, literally the standard library with some add-on utilities if you wanted to, and deploy them and run them on web app for containers, right? It's like a different flavor of Azure App Service, right? So you can definitely run Go apps on Azure. And this is a much more extensive example, right? What I presented was, like I said, a toy example, a very restricted or constrained example, but like you can use, this is like an e-commerce example, and as to how you might use Azure Web App Service in the context of a much larger system, and not just Azure Web App Service, but things like API gateways and CDN and blob storages for your product images, product information, so on and so forth, right? And not to forget authentication, security, so on and so forth. So hopefully this should give you some context, right, in terms of how you can use literally use Go applications and build Go applications and deploy them on web apps on Azure App Service and Web App for Containers. I like this one, container as a service. So like I said, with with Azure App Service, like containers is one of the options. With Azure Container Instance, which is, like I said, a container as a service on Azure, it's just about containers, right? There are some subtle differences. I'm going to come to that, but it's literally, the fastest way to get a container up and running on Azure, like literally the fastest way, I know at least, right? Just one single command, the one you see right here, az container create, give it your image, Docker Hub or private registry, whatever it is, container name, resource group on Azure, boom, you will have a container in a few seconds, like not like this, not like half a second, but maybe 5 to 10 seconds, right? Infrastructure is fully managed. You have per second billing, right? People tend to call it serverless. I personally don't think so, and there is a reason. I'll talk about that, but it is really good in terms of its speed and ease of use. And I was talking about these subtle differences, at least between Azure Web Apps, Azure Web App for Containers and container instances, right? So because of the per second billing feature, Azure Container Instances are very good fit for event-driven applications. So you have a logic built in, you have deployed that as a container and pushed it out to the cloud into Azure Container Instances, but it is not yet there, right? An event is going to trigger it, okay? You can build an API. You can build a web app with Azure Container Instances. No one is going to stop you, right? But it's going to be charged and built accordingly, right? So a very good use cases are event-driven applications, integration with Azure Logic Apps. I'm not an expert on Azure Logic Apps, but I've seen good things and how it integrates very well with Azure Container Instances. You could run build jobs and many other things, right? Like ETL jobs, so on and so forth. And one of the advanced use cases, which I'm going to talk to you and maybe even demo a little bit, is bursting these, bursting out with AKS or Azure Kubernetes Service. I'll leave that to later. I'm going to talk about that, right? And some of the features are, you can run things like, multiple containers as a single entity. You can persist your data and so on and so forth, right? All the good things, right? But I do want to make you understand that there is that difference between Azure Web App for Containers and Azure Container Instances in terms of the pricing model and how you might want to use it in order to best leverage that per second billing pricing model. This is a capability which I'm very happy and excited about. So remember I showed you that command, Azure CLI command, az create. So you can actually run it using Azure CLI, but you can actually do it with native Docker commands as well. So if you just set a context, and I'm going to try and demo this as well if I have time. So if you set your Docker context to work with ACI, you can just use Docker run and boom, you'll have a container of ACI right from your laptop right there. So I'm going to try and demo this as well. I'll be honest with you, there are certain limitations. It is not like built for complex orchestration, right? Like say Kubernetes. So it does lack a few things. So yeah, you should be aware of that. So again, just to set the context of what we were discussing so far, and I'll give you a moment to digest this thing as well. So we were talking about cloud native. We have talked about how you can use containers, and of course, we can't have a discussion of cloud native without talking about Kubernetes, and that brings me to Azure Kubernetes service, right? And I'm sorry if this looks like a marketing slide. That's not what I mean to do. Really, what I want you to understand, whether you're a developer, architect, or whatever it is, right? how important it is to have something like managed Kubernetes, right? And the amount of heavy lifting which a cloud provider can do for you. And this is not just about Azure. I'm not going to sugarcoat anything. It's for other cloud providers as well, right? So I really want you to realize how many, how difficult that job is to be able to, run Kubernetes clusters yourself. Yes, people do it. People are experts at that. The SRE folks, there are dedicated teams which people have, but not everyone can afford that, or that might not be their business or core functionality as a company or an organization or as a team, right? So manage Kubernetes, but then obviously no Kubernetes related discussion is complete without Kelsey Hightover. So in case you haven't heard, he's a highly respected developer advocate. Not at Microsoft, unfortunately. He's at Google, works a lot with GKE and containers and Kubernetes. But yeah, I think Kelsey has said it. So yeah, even managed Kubernetes has to be taken care of. So bear that in mind, right? Excuse me. There are like a lot of use cases for Kubernetes, literally no limits. This is just a few of them, but a specialty from a Go perspective would obviously be building these distributed single purpose microservices. Yeah, so Go is, like I said earlier, a very good fit for microservices and these distributed systems. And you could definitely build that on AKS as well. This is an advanced sort of use case. I'm going to try and demo this if I have to get through this real quick. Lots of resources for you to check out. So later when you see this, go click on these links. I swear it will be very helpful. And I think one of these, if I'm not mistaken, I think it's Learn Kubernetes, or maybe it's a series of short talks by none other than Brendan Burns, who I know was here on this forum as well some time back. So check these out. That brings me to Azure Functions, right? So it is FAS, or Functions as a Service. Contrary to popular belief, it's not serverless. I mean, there are a lot of servers. It is serverless, but you don't worry about it. Think about them. You don't have to manage them. It scales up and down elastically based on your workloads, and you only pay for what you use. This is like a bread and butter serverless definition. I've been doing this for a while, so I'm just going to zoom past this. Common use cases, again, bread and butter. You put in a file, you transform it into, say, docs to PDF, or real-time stream processing from event hubs or any other systems. And one of the interesting ones is extending SaaS applications. And again, these are just few of the use cases, right? Just a handful of them. And I'm going to talk about the last example here. I'm going to try and demo it again. I think I'm falling short of time, so I'm going to move a little quickly here. Yeah, this is an example. You can check it out later in the context of not just simple application, not just standalone, say, file processing or a backend, but in the context of a larger application and how you might work with different functions, not just one function, and how those functions will coordinate with each other, or maybe through a pub subsystem like a messaging system like Event Hubs, or a persistent system like Cosmos DB. So check this out. It'll give you good context in terms of how you can use it as a part of a bigger, much larger application, right? Yes, you can obviously use Go with Azure Functions. Again, it does not have first-class support. So Azure Functions supports Java, Python, JavaScript, of course, .NET as like first-class citizens. But there is something called custom handlers, which was released not too long back, I think a few months back. I might be wrong, but that doesn't matter. So there's something called custom handlers. So essentially, instead of just writing your small little function code, you write a little more, right? You write this web server, right? In Go, it can be in any language, right? Like I said. So this web server, and that is going to host your core function logic. And then the function platform, whatever that might be, it might be a local host or the Azure Functions platform is going to invoke this custom handler of yours, right? And I'm going to demo that hopefully pretty soon. So we are at demos, and we don't have a lot of time, but I'm going to try and do this anyway. Okay. So this is my plan. I have like 3 or 4 demos here. So first one is Go and Azure Functions. Okay. So this is a fun one, right? So I don't know if all of you use Slack, and if you use Slack, you use Jiffy or not, but let me get to the business right away. So the use case which I have is like building using Azure Functions to build a backend for Slack to invoke Azure Functions and do this funny stuff essentially. So let me go over to my browser. I hope I can you can still see everything properly. So this is my I spoiled it, so I'm going to delete this quickly. Okay, so if you have used Jiffy in Slack, so let me tell you, like, this is the out of the box Slack application. So if I say, hey, Jiffy cat, right, it's going to send me a bunch of options, right, and I can hit send and share it with my friends, all good, right? So what I have built is something called Funky, which is like, of course, a Jiffy clone, built as Azure, on top of an Azure function backend. So if I say, hey, Funky cat, give me a cat GIF, right? Yeah, so hopefully it should come back. And this was expected. It's not, don't worry, I'm not using the best plan. So typically this is because of a cold start, right? Don't worry about it. It's going to work in a while, hopefully. Yeah, so you see, right? So if I say, hey, Funky, so in runtime, what it is doing is I have specified the Slack backend right here. If I were to click on this edit button, this is my function, which I've actually configured as a Slack slash command. This is called a slash command. So this is my Slack app configuration right here for you, just for you to understand that it is real and it is working. Yeah, and that thing is going ahead and it invokes the Azure function, and boom, you have like a cool GIF, right? So funky cat, funky, why leave out dogs, right? I have neither. I'm not like a pet fan, but anyway, yeah. All right. Okay. So moving on. I'm moving quickly. I apologize because I know we have limited time here. So that's that. I actually wanted to show you an example of how to write one using Go. I don't think we have a lot of time, but I can definitely go over some of the logic here. Just give me a moment. Let me open and show you how this application really works, right? So at the end of the day, simply put, it is actually this, and I apologize if you're not a Go developer, you might not find this intuitive, but just stay with me here, right? So this is actually the web handler here, and what I do here in this main function is simply start a web server, right? Here with just by using this Go standard library. And this is the main logic for getting the request from Slack and doing the authentication, and finally it uses a Jiffy API. It invokes this Jiffy REST API to get that GIF and serialize it back to the Slack console and so on and so forth, right? At the end of the day, it is not magic at all. It is, like I said, a simple web server. It is, and trust me, although this is trivial, but it is pretty useful, and there are many useful applications which can be built on top of this construct, right? So it is, you should not ignore this. I mean, it's pretty powerful depending upon how you use and leverage it, right? So that's that. I also wanted to talk about how to deploy Go SDK, the application using Postgres and Azure Container Instances, but I don't think I'm going to have the time. But if I were to just quickly, real quick, show you as to how that even looks, right? So it is really simple, right? So if I were to just say Docker context and list, right? So now it is using the default context, right? So if I were to say Docker context, I already have something called ACI context set right here. So now, Docker context use ACI context. Now everything is going to point to Azure Container Instances, right? So if I do a Docker PS, you might not find anything here right now because there are no containers running, but you can actually do that. So if I were to quickly show you, let me open my copy pasta thing right here. Yeah, if I were to run this command right here, so this is a container which I already have in Docker Hub, and if I were to try and run this, like Docker run, boom, like that's it. You just imagine, right? You are using native Docker, not Azure CLI, nothing, and this is now started to spin up a container in Azure Container Instances in the cloud, right? So right now it is creating a container group, and right now this is spinning up a function right here. And once it is over, you will see that it'll spit out a bunch of logs as well, right? The application which I had was, it simply runs and pushes a bunch of rows into PostgreSQL, which is again running on Azure. So just to make sure that I'm not fooling around, I can go and show this to you. So if I were to look for container instances, and if I search with this name, hopefully it should come up. Okay. Yeah, so you see this is just here. The status actually should update itself pretty soon. So you see it is succeeded, right? So it just ran once and boom, that's it. So it is in a stop, actually in it's not like running right now. It ran once and it succeeded, that's it. So you'll have to trigger it again and again. So that's the way it works. Going back real quick to my presentation. Yeah, I also wanted to show you this in terms of how to scale Go applications with a project called Keda. It's called, go to keda.sh if you're interested. So essentially, I'll give you a high level overview, right? So I have like an Azure cache for Redis provision somewhere. I was, if I push and I have a Go producer application, and I have a consumer within a Kubernetes cluster in Azure, right, along with Keda. So what Keda does is it's like magic, right? Don't worry if you don't know about it, it's fine. What it helps is auto scale your pods or your applications on Kubernetes. It's a custom operator, and it not only gives you like scale from 0 or 1 to literally infinity, but it also scales back down to 0 or 1 if you wanted it to, right? So think about the saving resources and not having those application instances running if you don't want them to, right? So for example, in this case, if you push events or items into a Redis list, your application would auto scale thanks to Keda based on the amount of items you have in those lists or the length of the list, right? So that's the beauty right here, right there. Of auto scaling Go apps. I know I went a little over. We don't have a lot of time for Q&A. I don't know if you can extend beyond the stipulated time, but I am more than happy to stick around and take Q&A. So, or if you can't, like, don't be shy. Absolutely don't be. Please reach out to me on any of these platforms. I'm on Twitter, GitHub, start my project, send PRs, complain, whatever it is. I blog a lot on Medium and Dev2O, so just drop in a comment if you find something useful or not so useful. Just reach out, right? And thank you so much once again for having me. I know I couldn't do all the cool demos which I had planned for you and some live coding as well, but that's okay. I can probably come back and do that later sometime. So it's open for questions, Nilesh and co. If, again, like I said, I know I ran a little over, but I am more than happy to take questions.
We don't have a hard limit, Abhishek. So if you want to have a quick demo, something cool, you could still go ahead and show it.
Oh, okay, that is awesome. Okay, I definitely let me then switch over. Okay, so let me think about this, right? So I had a bunch of demos, like I said, and why not? Okay, so I'll show you something relatively simple. Given some time, so I'll start with Go plus Azure functions, right, and try to build something very simple from scratch, right? So let me open that project here. So hold on. Demo Azure function and this demo function. Okay, cool, awesome. Okay, so what I'm going to try and build is, so you saw that that application which I had just showed you. Now let me try and build something from scratch here, right? So I'm going to build a very simple Go web server, like I said, which I will later deploy to Azure functions, right? So again, don't worry if you're not a Go expert. This is like really simple. I'm going to walk you through it, right? And that might take a little bit of time, but that's perfectly cool, right? So sorry. So this is like a main function, like I said, and now I'm going to write a very simple Go web handler, right? So it's going to be called hello, not hell, obviously not. It's hello, and web handlers in Go are typically with this particular signature. So it's a response writer, and the request is a pointer to a HTTP request, right? And I'm going to show you, I'm going to plug in this handler later on, right? So what I'm going to do, very simple. I'm going to say, hey, if the request dot method is if it's a get, for example, do this, or else if again, I'm trying to keep. This is not sophisticated at all, but I'm just trying to give you an idea, and when we'll run it, you'll see what's going on, right? So do this or do that, right? If it's a get, respond with a simple, a byte array in this case, and it'll just, hello. The time is time dot now dot string, right? It's like a time server, right? If you invoke it, and say you invoke it with a post with some payload, right? So let's read that payload, right? So you can do that with something called IOUtil. Again, go standard library dot read all, okay, and you have to read in the request body, request dot body, right? And this is all going to be read as a byte array again, and we'll do some, ignore error handling for the sake of time. Don't do that in production, right? So this is, I've ignored the error here, right? And what we can do is simply write back this byte array, right? Simple, right? I mean, I don't want to complicate this too much. Okay, so very simple. If you do a get, it'll give you the time. If you do a post with a payload, it'll echo that thing back to you. Very simple. Now let's like wire this up. Okay, so I'll do an HTTP. I'm invoking the net/HTTP standard library, handle the func, and this is going to be an /API/demo. This is the route, and I'll tell you why it is. The route is API/demo. I'll tell you. And here is where I've wired the handler right here. Okay, and yeah, you know what? That's pretty much it. All I need to do is start off this server with listen and serve. Pretty simple, right? So. And I need a port, and I'll show you what that port is in a minute. And don't worry about the nil part here. Nil is actually a handler, but we don't need a handler because we have explicitly associated a handler over here, right? And what about the port? So port is actually, I'm going to read from environment variable. So OS is another package, or within the standard library. And I think the name was functions underscore custom handler. If I can type. Oops, handler underscore port. You know what? I have a cheat sheet. So now this is something which the environment, the Azure Functions environment actually does. So this is why I'm having a hard time remembering this. Yeah, it was functions underscore custom handler underscore port. I'm going to copy paste that. Anyway, I think it was right. Okay, right. So I'm going to read it, and if it's not there, if port is, if it's blank, I'm going to just set it explicitly to, say 8080, right? Just to make sure, print. Okay, listening on, yeah, and port. That's it. Okay. Now. That's it, right? This is all which our function needs, right? Simple handler, get, post, boom, right? How do we actually run this, right? So where is the magic? So if you look at this file called function.json, and you've done any development with Azure Functions, you will be aware of these function.json, host.json. If you've not done, don't worry about it. Nothing very magical, right? It's just think of it as configuration or metadata, right? In this function.json, if you look at the folder name, it is very important. This is actually a very prescribed structure, application structure for your function in order to run these custom handlers, right? So the function name is going to be demo when I'm going to deploy it, okay? And it is going to be actually running off of this particular route, right? So this is this is the route where the functions host is going to invoke your web server, which is this, right? This is going to be, and this is like a predefined one. This is exactly why I have defined this host in my web server handler right here, okay? And this is nothing. It says it's an HTTP trigger, right? So this is going to be triggered off of a HTTP event, post or get. This could be event hubs. This could be Cosmos DB. This could be anything, right? So HTTP is just one of those triggers or bindings. Right? So that's the magic of function.json, and the other one is host.json, right? So I'm activating these something called an extension, right, which helps you use these triggers and bindings. And this is actually the name. This is a custom handler property right here. So what it does is it gives the name of the executable which will be called when this function is run, right? In this case, like I said, Go is actually compiled to a binary. So I am going to build this demo func binary, and I've given the explicit name right here, right? So this will be used when my function is brought to life. Okay. So what I'm going to do now is simply, and I'm going to just make sure I don't fool around. So I'm going to do a local deployment. Okay. So to do a local deployment, I'm going to build this function. I'm going to do an rm demo func. I'll delete the binary which I have right now. So there's no demo func right here. I'm going to do, so I have a Mac. So I'm going to compile this for a Mac and go build -o, and the name is demo func. This is the name of my binary, the binary itself. Oh, sorry, this is a typo here, so it wouldn't work. It's Go operating system, right? It's Goose. It's a funny one, I know. So you should see, right? So we have a demo func binary right here. That's it, right? So I can use the Azure Functions core tools called func to simply start it, right? Don't worry, it's just a tool set. You can download and use it. And I'm going to do this locally now, right? This is going to run locally on my machine, just to make sure I haven't missed anything. I think this is going to, yeah, we'll see. Func start, boom. Okay, so this is now started. Let's see how this goes. Okay, so listening on this port, this is the output from my function. If you see right here, this is the one, and looks like it has started. Okay, so like I said, this is excuse me. Yeah. So this is actually the URL, the HTTP endpoint at which using which I can actually invoke and interact with my function. Right now, I'm going to do this locally for now. So I'll just open a new window and do a curl. And hopefully, yeah, so it gives you like, hello, the time is blah, blah, blah. If you do this again, it'll give you a different time. So you see, right, I'm not fooling around, it's actually working. And if I were to do the same thing, right, for say a post, yeah, minus, so if I do a post and I have, a payload here, it's going to echo that back to us, right? So in this case, it was foobar, and yeah, it's going to do that again and again, obviously. All right, all fair, all good, working locally. I'm going to stop this right now, and I'm going to try and deploy this to Azure, right, to the Azure Functions platform. So I am going to deploy it to something called a function app. If you haven't heard it, don't worry, it's just like a container for different. When I say container, not the Docker container, like a namespace for different functions, right? So I have a function name, a function already created, function app, sorry, not function, called Gopher func. Let me go to the, let me just show that to you real quick here. If I go here, I have just hold on a second. So Gopher func, this is the app, right? This is not the function. This is the function app, to which I'm going to deploy the function right now, right? So the function name, like I said, will be demo. Sorry, let me go over to yeah, VS Code right here, right? And nothing different. So what I'm going to do, the only different thing is I'm going to run this on a Linux-based infrastructure within Azure. So I'm going to deploy or cross-compile this binary first. I'm going to delete this demo func, and just run this for or rather compile this for Linux now. Okay, so I have a new binary, and this will work for Linux. And just copy and paste this command. Nothing magical here. It is going to deploy this. It's going to build, package it up, and then push it to Azure. It might take, let's see, hopefully it's able to do it quickly. 3.75 MB based on my internet connection. It's going pretty well so far. All right, so it's uploading the package now to Azure Function. Like I said, it is the name of the app is Gopher func, and the name of the function itself is demo, right? And I'm going to be able to access this pretty soon over an HTTP endpoint, which I'll get pretty soon as an output of this command, right? So again, all I'm doing is using the Azure Core Functions tools. Nothing new. Like this func command comes from there. You can deploy, install this on your systems, right? So deployment complete. It is syncing stuff, doing all the good stuff, and doing something useful for us. You will see just now. So yeah, all right, cool. So and see the nice stuff. It has given us the invoke URL right here. But just to show this to you, if I were to go back and to my Azure portal right here and go and peek into the list of functions, you will see that I have a function by the name demo. And and this is the same function URL, the one which you see in here, right? Okay, so let's try and deploy this. I'm sorry, let's try and invoke this. So the same exercise, curl. So this is going to do a get, right? So get, okay, right? So this works. And if I were to do the same thing, say, excuse me, curl, and same thing, post, and let's try like everyone likes JSON, right? So JSON, okay, JSON payload here. So it's going to work the same way, hopefully. Foo bar, blah, blah, blah. And if I can type, and I'm going to just beautify this for you. So yeah, you see, right? It echoed us back with the same thing, right? Foo bar, nothing special, but it works. And the key goal here is to make you understand that it is definitely not magic. Custom handlers, you can build Go applications with Azure Functions, even though they are not supported first class. I wish they would be. Maybe they will be in the future. Who knows? But you can do it if you want to. Absolutely, you can do like everything you want within this function right here, right? That's that in terms of my first demo. I have a few more, Nilesh. I can go through them. I would be more than happy to. Just let me know if I'm like, yeah, just interrupting, just stopping here for a while, for a little bit, just to get your input. Like,
I think for now it looks all good, Abhishek. Because it's already 9:15 in Singapore, so I don't want to hold people back from maybe dinner. We could definitely arrange for a follow-up session and have more deep dive kind of things. It really looks interesting.
Yeah. I mean, I would love to have like a session where just for live coding and demos, right? I think that'll be good.
Yeah.
Cool. Awesome. Awesome. So I'm going to stop sharing now, if that's okay, Nilesh?
Yeah. Yes.
All right. Cool.
So I think we can open it up for Q&A.
Yeah, absolutely. I'll be happy
to take some questions. If I don't see anything in the chat window, nobody has asked any questions so far. There was one on YouTube channel. This was more like a comment, I think, on one of your slide. The person is Hassan Abu Bakar. He is asking, or he's saying high performance and low memory is not part of good parts. So I think you had a slide which was talking about the good parts of Go. And there was something around high performance and low memory. And he's asking, is it not part of the good parts? Of Go, and there was this question around high performance and low memory. Is it not part of good parts? I think that was like a comment or a question.
Oh yeah, absolutely. Yes, most definitely, right? So I think this is what you were alluding to, which I was talking about specifically. How is Go suitable or very well, in terms of the cloud? So yes, these are just, like I said, these are just few of my picks, and the context here is typically for someone who is getting started, and that was my context here, right? So when I say my top picks, but obviously there are so many other things. People talk about readability. People also talk about concurrency being, they love the concurrency, aspects of Go. There's so many other things. Definitely it is there. And alluding to your point, Hassan, it's the performance and the low resource overhead. definitely a good part, a highlight of Go. Just the fact that I did not highlight it here, it could be like, number 5 or 6, or I can only talk about so many things. But yes, definitely a good part about Go there, for sure.
Okay. I would say, Abhishek, you have definitely evangelized Go to a great extent. I always wanted to learn about Go, but never had time to go and explore more. I know a couple of my friends, they are really doing Go, and they keep telling me you should have a look at Go. Now I will definitely go and have a look at Go.
Yes,
So,
please. Yes, please do. I mean, yeah, joining the Go community, it is awesome. Yeah, please do. Yes, and I have like it's again my prescriptive way of potentially how you can get started. It's by my experience, and even a lot of other folks in the community. But of course, feel free to find your own ways, styles, and things of and ways of doing things or learning Go your own way. Yeah. Absolutely.
Would you be able to share this slide deck?
Yes. So I am quickly going to, just 1 second, just to make sure. So this is the URL right here. Very soon, I'm going to publish the slide deck, the link to the slide deck, and a lot of other resources on this URL. So aka.ms/Azure for Gophers. Hopefully, I don't know, Nilesh, if you can help, just ensure that this is publicized enough for folks to go check out, because this is going to be one of the things. But I know they can obviously go and take a look at the recording again. But yeah, I'm going to publish everything. So just to answer your question, TLDR, yes, everything is going to be there here.
Yeah. I found some great resources there. So definitely it would help the community and people who will be watching this session later on YouTube. I will make sure I put it in the meetup as well as the description of the YouTube video.
Yep.
So I think what I would like to do is if anybody in the audience has any questions, maybe we can take 1 or 2 and then close it off at this point of time. So if anybody has a question, please unmute yourself and you can ask.
Yes, please feel free.
Hi, Abhishek. This is Jay from Sydney. I was just wondering, what's the most prolific project you've ever seen implemented using Go?
The most prolific project, I would have to say Kubernetes. Right? I mean, it is a monster of a project. Well, it's not just a project, right? So let me quickly go back to that slide as well, just to make sure, right? So Kubernetes, definitely the most sophisticated thing I know of built in Go. Obviously Docker, and the other ones which I have mentioned are simply based out of, they are just my interests, right? Because I work on messaging systems a lot, I work on databases a lot. So yeah, definitely Nats and Prometheus and things like Vitess also count in. But if I were to give you a one-liner, Kubernetes by far the most sophisticated project in Go. Like I said, Docker, Kubernetes, poster child for Golang.
Awesome. Thank you.
I had a question, Abhishek, around that. Looks like Go is quite popular when it comes to like building backend services or something which runs more like a process, and not so much when it comes to the web front end or things like that. Is that right to say?
Yeah, a good question. So like I said here, right? It is very good for backend, server-side, applications, APIs. You could build front ends with it. I will be honest with you, I'm not like super. I'm like, I don't know front end at all. But there are technologies, right, which you can use. I think Webpack is one of them. Or you know what? Forget it. I'm not going to talk about that too much. But when I say web and APIs, I do want to clarify once again that it is more of, it's not full stack applications, but that is something you can absolutely do. So you can, for example, have like a very dumb sort of a front end, right? You can have all your static assets packaged and everything, and running as like a Go application. You know what? Actually, this one of the examples which I had for just give me a second, and this is important because it is a very I think pertinent example in this case. Let me try and look for this. Yeah, so this is the cognitive services example which I have. It actually packages that web front end as the entire application in the form of a single binary. You could try that out, but definitely I would not say that Go is a front runner for building web front ends right now in the best of my knowledge. No. APIs, backend system, HTTP APIs, gRPC APIs, whatever APIs, right? Build it with Go. Networking services, build it with Go. Front ends, maybe not. I have seen people, there's a project called TinyGo using it for embedded services. I'm not an embedded expert, but you could do that. Why not, right? So yeah, but sorry to digress, but not web front ends, purely front ends are not something which Go is very, very popular for, but I'm sure you could do it.
Okay.
Yeah.
Thank you.
Thanks for the question.
So I think so. Anybody else has got any other question? Okay, looks like that's it for the day, Abhishek. Thank you. Thanks a lot for taking time and having this wonderful session. I hope we will have much more from you coming in future, and definitely hope to see you someday in Singapore when things go back to normal.
Oh, absolutely. Thank you so much, Nilesh. I appreciate it.